Good morning. Today we're going to be taking a look at some more with the Java math. Specifically, we're looking at numeric casting as well as random. As you can see right here, I have my scanner that I'm using so I can pause my input between what we're working with, and I have that initialized inside my constructor just like normal. We're going to start with our start method. I know, crazy. In my start method, as you can see, we're going to be working with three specific methods this time. We're looking at explicit casting, so we can talk about casting explicitly, then we'll go to implicit casting, and finally we'll use that information so we can go through and do some random numbers, because that's the reason why we're talking about casting in the first place, is so we can actually talk about how we can use random numbers using Java. Let's go ahead and take a look at the explicit casting method, where we can demonstrate the use of explicit casting of values using ints and doubles. And so we have our method right here, and as you can see, I've got my private void explicit casting for my header. I declare a couple int values, and then I have the statements of how I do the division operation, so we can actually see what happens when we cast and when we don't cast the information, and then display the results using system.println statements. I then use the keyboard input.next line to pause my information as I wait to switch to the next screen. Then we'll go ahead and work with doubles again and do the same thing. And notice again, there's a quick comment right there as we actually talk about the double section, because we have to have the full value. So let's go ahead and run the code and we'll get started from there. So we have our results of normal int division are 0, because when I take that first 5 divided by 10, since 5 is less than 10, it's half of it, then we're just going to cut that off, because when we talk about integers, when I do int division, if the number on the numerator is smaller, I'm going to automatically get 0, because there are 0 tens that fit into 5. And so int division has no access whatsoever to fractional values. Then we do the double cast division result when we do parens round double, and we cast the entire result of first divided by second. And so because I'm casting that entire result of first divided by second, those two int values, I do that as a int division, so that gives me 0 as my result. And then I cast that value as a double, which gives me 0.0. So I simply just add a decimal 0 to the end of that result. No big deal, doesn't really give us much information. However, when I cast either only the numerator or only the denominator, you can see that I get the result of 0.5. I actually get the actual mathematical information I want when I'm doing division. And so when you're looking at the idea of casting information, you want to make sure you actually grab the information you want when you're working with division. So if you're taking int values and you want to actually get the fractional or the real value out of it, you only want to cast part of it, or if you really, really want to, you can cast both the numerator and the denominator, but you'll have to make sure you have to make sure that you cast part of it so you can actually do the value as a double division. Otherwise, you'll only get the int value and then just append a .0 to that, which is not really helpful. So when you're working with casting to a double, you want to make sure if you want to capture that information that you do any of that calculation before if you want to capture the information that's in the actual mathematical operations, you need to make sure that you cast as a double before you actually perform the operation. Otherwise, all that information is lost, because when you do with any fractional values in int, it's all wiped off and it's gone. We'll then go ahead and use our keyboard input next line so we can actually switch to the next line right here. So we'll press enter, and we go right here, double third and fourth. We have pi, and we have 5.6789. I know, some lovely numbers right there. And I double cast division fourth over fifth, and I get the 1.8077. And then I have int cast as division, int fourth over fifth, and I have to cast the entire value on that, because if I try and cast only part of that, in that case that's commented out, int fourth divided by third, I still have a fractional value, as we saw up above on lines 37 and 38, because I actually have a decimal value still left on that, because I only cast part of it. So whenever we're working with casting down to an int, we have to make sure that we cast the entire result. Otherwise, it's going to give us an error message, because you can't compile into an int when you have any fractional values. So that's why we have that information right there. And so whenever you're working to cast it down to an int, you have to make sure that you explicitly cast the entire result. Otherwise, if there's any decimal, fractional value, whatever, it's not going to work. It's going to give you a compilation error, and you can't actually proceed from there. Because a double can have, no int value, or a double can have an int value only, no decimals. Hey, that's no big deal. I can totally deal with that. I'll just add append a 0.0 to that. I can add that useless extra information to there. But I can't take that extra information and somehow put that into an int. I have to cast it as an int to make sure it'll actually fit inside that box. Otherwise, it's not going to work. So when we're talking about explicit casting, it's really important. If we want to go down to an int, we cast the values in there. When I'm casting up into a double, if I don't have actual values, I'll just append a .0 to it. No big deal. But if I want to get the actual math, I want to cast part, then do the math, and then I can actually cast it into things so I can actually capture that information and store that division in a double value. So that's where we go from there. Let's go ahead and continue on. Let's take a look at using implicit casting as well. We can do implicit casting when we're using the assignment and the math and assignment operators like plus equals, divide equals, minus equals, times equals, even modulo equals. And so we have int implicit demo int is equal to 5, and then my system.println original value is implicit demo int, so I get that lovely 5 right there. And then I'm going to append 3.14. I can't actually just add 3.14 or subtract 3.14 or multiply 3.14 to an int, if I use the plus, minus, divide, multiply, or modulo equals, I can totally put that into an int because it'll just do the implicit casting and then assign the value into the int automatically. So I can do that with there. And so that has that operation right there where I can take that lovely 5 and I can implicitly cast that. I simply just get a value of 1 from that, so it's okay. And then we have our double implicit casting 4.1234, and then I print that double value. But because it's a double, I can simply just, I'm going to do it in division, in subtraction, multiplication, division, whatever. No big deal. I won't hurt that. And when I multiply that, I'm going to go ahead and I'm good with that right there. And on the implicit demo, and I have that 1 times that's now the same thing of 4.1234. So nothing happens with that because, well, it's just multiplying by 1. Hey, no big deal. Doesn't change anything. Let's go ahead and let's use that explicit casting so we can actually learn about how we can work with random numbers in Java. So we're going to work with pseudo-random numbers right here. We use the Math.random function to actually access and create pseudo-random numbers in Java. And so you can see right here on line 87, we have double random is equal to Math.random. And so when I create a random number in Java, I'm going to get a number between 0 inclusive and 1 exclusive. So I can't go up to 1, but I can get really, really, really close. So as long as my random number is greater than 0.003, and again, I'm using the underscore right there so I can easily make it easy to read. I was doing a much bigger demo earlier today, so that's why that came. But I'm like, I'm going to print that random number out, and I'll continue printing that value until I get a value that's no longer greater than 0.003. So I'll go ahead and run my code right here, press enter to continue. And I have, as you can see right here, I've got quite a few executions of that statement. Oh, quite a few stuff. Oh, there's a whole bunch of lines. So it took a while for that to happen before I got to 0.003 or smaller. And so as you can see, quite a few different iterations of that happened. That while loop executed quite a bit. And so we go ahead and do the next line till we get that next stop. And we get our new random number. And this is where we're going to get more often how we're going to work with random in this class in Java is we're going to make a random int. And so if I want to get a random number, I'm going to take the number and I have to cast it as an int. But in order to do anything useful, I have to make sure I scale that value. And so I have a scalar right here. In this case, it's 10, so I can get 10 different values. And so int random number is going to cast as an int, and then the value result of Math.random times 10. So I want to make sure I capture that entire thing. Because if I don't put the parens around the entire thing, all I'm casting as an int would just be Math.random. And all that would give me automatically, since I'm casting 0 point something to an int, would give me 0. 0 times anything is always 0, which isn't useful. So we don't do that. So I want to make sure I cast the entire value as a int so I can actually get the results from that. So do Math.random times 10, that gives me a number somewhere between 0 and 10. Oh, so a Math.random number is not equal to 10. Okay, cool. So we'll go ahead and I'll continue on with this, and I'll press enter, and oh, it's not stopping. It'll never stop because, again, because this only gives me between 0 up to and not including 1. When I multiply that by 10, it'll never actually meet that number. So it's never actually going to get to 10, so I'm stuck with that. Oh, that's not useful. So let's go ahead and we'll change this. Instead of not equal to 10, let's make it not equal to 0. Go ahead and save that again. We'll rerun our code. And so we'll rerun our code from this point, and we press this, and oh, here's my random number. And so I have a random integer. I've got quite a few values before I get to a 0. So random integer 6, 8, 2, 6, 1, 4, 4, 2, 9, all da da da. And so that's not exactly 10% of the values, even though I should be getting an approximation of that, but that's an approximation over time, not simply just 10. So make sure you keep that in mind. So I've got that random integer I'm calculating with that. I can also shift my random number so I can have it so it's going to go across a range of values. And so I use that same approach, shifted random. Again, I mean, I want to have 10 numbers, but I want to have it up to between 5, but not including 15. So that value right there, Math.random times 10 plus 5. So I do the scaling first, then I shift that value up the number line by 5. If I want to shift it down the number line, I move it -5. Oh, no big deal. And so when I continue on with that, I have my random integer 11, 7, 10, 12, and 6. Because that loop iterated until it was less than 13. So that last time I iterated, I somehow got a number that was 13 or greater because it could either be 13 or 14 within that realm of values that were acceptable. And so when we're working with this, we have the idea of a scalar. That's how big the range is going to be. And you want to remember when you're working with that scalar, it's up to but not including that number because we start off counting at 0. So keep that in mind when you're working with that so you can keep that going for there. And if you want to shift that value on the number line, that's where you have the shift right here. It can be either positive or negative, however arbitrarily much you want to go from that. And so that'll take you left or right along the number line when you're working with that value. And so that's how you can do a shifted number. And again, we did this because we used casting on that. You want to make sure that you explicitly cast the value as an int and cast the entire result to capture the information. So you do the math first, then cast as an int to get the actual information when you're working with double values. I hope this is helpful for you. Cheers, have a great day. We'll see you next time. Bye-bye.